Welcome to Theme 3.1's practice session. So we will be doing some textbook problems and some past paper problems. The textbook problems will be out of your textbook in exercise 16.1. We will be doing question 15 and 22. So just note that usually in question papers, they don't ask directly to sketch a vector field. It is a possibility for them to ask it, but vector fields get integrated into the later themes. So you just have to understand how a vector field works and to sketch it, because they can ask you to sketch it. So in the first question, they ask to sketch the vector field that has been given. So first, what you can do is choose some points on your own where you want to sketch this. You can start at 0, 0, 0, or whatever you would want, just so that you can get an idea of what the vector field looks like. So let's say we choose F 0, 0, 0. So this will be at the point where z, x, and y is 0. So it will be here. So at that point, we will have a vector that is 1, 2, and 0. So this will be our vector there. So the magnitude in the x direction is 1, and the magnitude in the y direction is 2, and the magnitude in the z direction is 0. So this vector is basically going to lie on the xy plane. So it'll lie approximately more to the y side. So it'll look like this, and this will be 2 and 1. Okay, so that is just your first vector. Now let's say, okay, let's jazz it up, and we want it to be on the z-axis. So now we have 0, 0, 1. So we only want it to be on the z-axis. It's just easier to see. So that'll give us 1, 2, 1. Okay, so the point that we have is here, and it'll be the same magnitude to the x and y direction as before, but now it has a magnitude of 1 to the x direction, so it'll go up. So this point here, or this vector, will have these magnitudes towards the x, y, and z direction. Normally, they might ask you to draw the vector field on the xy diagram, so then you'll just have magnitudes for the x and the y and not the z as well. So the next question asks, find the gradient vector field, del f, of this function and sketch it. So first, let's find the gradient vector field. So previously, in the theory session we had for theme 3.1, there was a recap on how to get the gradient vector field. Since this kind of integrates theme 1 work, you can just go check that out. So to get the gradient vector, we need to get the partial derivatives of this function towards s and t. So the partial derivative towards s, so we have 3s, you can just work that out. So it'll be 3, it'll be 3 over 2 root 3s plus 2t. Just check on that. And then for t, it'll be almost the same. So you'll have 2 at the top, and then you take into account this, and then you have this. So these are your two partial derivatives that you need, and then you can get your del f, which you then include this and that. To sketch it, all you have to do is you have to choose points for s and t. So let's take points for s and t of 0. So you'll have del f 0, 0. And that will give us, if we put 0 in here, that'll give us 3/2 and 1. So then you can sketch that. So here is your point. Let's say this is your t-axis. And this is your s-axis. So at this point, you have a magnitude for your s of 3/2, which is about here. And for your t, you have 1. So then your vector just lies here. Okay, so that you can continue to do with other types of variables for s and t, and then you can just sketch them on the graph. So going to past paper questions. So we're going to do exam 2009. Note that in the past paper questions, they don't include vector fields mostly on their own. So some of these questions I have taken and made a variation just to practice gradient vector fields and vectors on their own. So question 1, they're asking us again to find the gradient vector at this certain point. So this is our function and the point that we have to get it at. So first things first, we have to get the gradient vector, and as previously I've mentioned, we need the partial derivatives. So the partial derivative towards x is 4x plus y squared minus 3x squared. And then towards y, we have 2xy plus 9y squared. Note that this is a 3 if it's not clear. So now we have our partial derivatives. So we can now get our gradient vector field of x, y. So then we just put this in here and that in there. But they ask for this vector field at a specific point. So all we do is we take the point, the x and y values, the coordinate, and we put the x and the y's into these equations. So you'll have 4 times -2 plus 1 squared minus 3 times -2 squared. So this is your partial derivative towards x, and you just subbed in the x and y values, and then you do the same for the partial derivative towards y. So you'll have this. And then you just simplify this for yourself. And you can just add these up, and that will give you, it should give you this. So on to the next past paper question from 2011. So it's also question 1. They're asking us basically the same. This is just for practice so you understand how the vector fields work. So you do exactly what you did previously. Note that they like to repeat some questions in the past papers. When I wrote, I figured that happened a lot. But we also always prepare as if it doesn't happen, so that you can work without remembering. So what you do now is we have 3 components. So we have x, y, and z. So what we need to do is we have 3 partial derivatives in this case. So it's just a bit of a longer process. So your partial derivative towards x will be 3y cubed minus 8x. Towards y, it'll be 2y plus 9xy squared. And then towards z, you have 2z. Okay, so now you have your gradient vector, which will just look like this. So you add in the x, and then the z, and then the x, the y, and then the z. And then you have your gradient vector. So if we want it at a point, we do like we did in the previous question. We just use this point, which needs a z value, which was 0. So you have 1, 3, and 0. So then you just add that in. So del f 1, 3, 0 is equal to, and then you just put that into your partial derivatives as you would previously. And then when you put it in, it will look like this. And then you can just sum all of that and get your questions. So that is the practice problems for theme 3.1.